Now, first solid to liquid completed. Liquid to vapor is also completed now. Completed now. Children, tell me.
No, sir.
Right. Now, these two is completed now. Completed now.
Yes, sir.
Liquid to vapor or gas. So that equilibria in vaporization. So observed in closed vessel. Closed vessel. Right, children. So what will be happening? Let me discuss. I am taking, this is a vessel. A vessel. Now, this vessel I am taking the water. This is water. Water. Now, for water. Initially this is a water is going to vaporization. Already why the water getting the vaporization? We discussed in our liquid state. Nothing but states of matter, vaporization, condensation. Those all things I explained you. It's called as vaporization. Conversion of vapor phase molecule is liquid phase. This is called as condensation. Condensation. So initially this is process is called as vaporization. Vaporization. So initially rate of vaporization is greater, rate of condensation is slow. As going to the time, rate of vaporization decreases and rate of condensation will be increased. After some time, at equilibrium state, rate of vaporization equals to rate of condensation. Rate of condensation. At this equilibrium is exists between the vapor to liquid, liquid to vaporization process. Equilibrium is established. For the example, at 100 degrees C and 1 atm pressure, okay, H2O is in a liquid state, is equilibrium with H2O. H2O is in a vapor state. Children, it's clear? Children, it's clear now. Now, this is also completed. Now, let me discuss about the equilibrium in a dissolution of solid in liquid. Equilibrium in a dissolution of water. This vessel containing water. This is water. Okay. Now, at this state, a little bit amount of cane sugar. This is the cane sugar. Is dropped into this one. This is cane sugar dropped into this one. Now, these cane sugar crystals are splits to cane sugar molecules, sucrose molecules, like this. At the after completion of or saturation of this one, okay, a little bit amount of substance is there. This is a undissolved cane sugar. This is undissolved sugar. This is a dissolved sugar. Dissolved sugar. So after formation of this one saturated, this is completely then. So dissolution of decomposition of cane sugar molecules from crystallization form to dissolution form is called as a rate of dissolution. Now at the same time, okay, these cane sugar molecules are associates with each other. Let it down here that it is a rate of crystallization. Rate of crystallization. Right, children? This is the rate of dissolution, rate of crystallization. One molecule already in the yesterday class చెప్పాను కదా తల్లి ఫస్ట్ ఫ్లోర్ నుంచి సెకండ్ ఫ్లోర్ కి సెకండ్ ఫ్లోర్ నుంచి ఫస్ట్ ఫ్లోర్ కి అంటే ఒక పర్సన్ డౌన్ అయితే ఒక పర్సన్ ఏమవుతుంది అప్ అవుతుంది సో ద నంబర్ ఆఫ్ పీపుల్స్ ఇన్ ద ఫస్ట్ ఫ్లోర్ అండ్ సెకండ్ ఫ్లోర్ ఇస్ ఆల్వేస్ సేమ్ అంటే at the same time one cane sugar molecule from the undissolved state to going to the dissolved state. At the same time, dissolved molecule becomes a undissolved state. Means this is process is a rate of dissolution. This process is a rate of crystallization after a particular time. Such a state is called as a equilibrium state. At equilibrium state, rate of dissolution should be equals to rate of crystallization. Children, it's clear now? Understand?
Yes, sir.
Apply this thing to any. Okay, those tell me.
Sir, the rate of crystallization means again those molecules will bind up, sir.
Yes. This molecule is in dissolved state. Dissolved state. These are separated by the water molecules. By increasing the concentration of these molecules in water, they combines with each other, settle down here in the solid form. Clear na? Solid form comes out like this. This is called as a rate of crystallization.
Okay, sir.
Right. Clear. Is anybody doubt, ma?
Sir, even in an open vessel, it forms crystals, sir.
It is a open vessel is also it is existent. Okay. Somewhere there is gaseous components, it should be in the closed vessel. Otherwise, it is not made to closed vessel. Clear na? If any gaseous components
Yes,
need
sir.
the closed vessel. Right. Why? Because these gaseous components are escapes from the system. That's why we require that closed vessel. Now, equilibrium in a equilibrium in a dissolution of gas in liquid. Gas in liquid, right, children? So generally we know that aquatic lives are utilizing the dissolved oxygen, that it is DO. It's clear? Children, tell me.
Yes, sir. Fishes.
They are respirating the dissolved oxygen, this dissolved oxygen. Then what is the meaning of dissolved oxygen, children? For the example, what I am taking?
Oxygen mixed with water.
Oxygen is dissolved in water, right? Now let me take the example for this one. This is water for the example in beaker. Now this is atmospheric air, na? The open after this surface, this air contains may N2 gas, may O2 gas, may CO2 gas, may SO2 gas. These all are the gas are present over this one. When this oxygen molecule comes close to here, then dissolved into and enter into this water. So this is called as a dissolved oxygen. Dissolved O2 means DO. Okay. So at the beginning of this state, rate of dissolution is greater. Rate of dissolution is greater. As going to the time, children, as going to the oxygen molecule much more greater after saturation, they may collide with each other. This O2 molecule will escapes into the atmosphere. So this is called as a dissolution. Dissolution. This is called as a vaporization. Vaporization. Now dissolution, okay, as going to the equals to vaporization. Rate of vaporization. Okay, in that state is considered as a equilibrium state. Clear. Rate of dissolution equals to rate of vaporization. It's clear, children. So some soda water is like that distillery water. Why did you observe, children? This is the distillery water for the example.
CO2 is
Yes, if you are opening this lid, some phases are observed.
from the bottle, sir.
Yes, some phases are comes out. Reason, at high pressure, this gas means generally we are using this one oxygen or CO2. Generally CO2 ni man dintlo dissolve chestam. So at high pressure, if you are removing the pressure, this gas will comes out. Okay. Now dissolution of gas is directly proportional to pressure of gas. Pressure of gas and inversely proportional to temperature. Banu, clear, Natali?
Clear, sir.
So once
As increasing as increasing the pressure, solubility increases. Means, for example, if you are taking the 1 atm pressure, solubility of O2 is 1 milligrams per liter. 1 milligram of O2 is dissolved in 1 liter. If you going to the 2 atm pressure, then randomly its mass dissolving quantity is also increases. At 2 atm pressure, it should be greater than, means for the example 1.5 milligrams per liter. So solubility of the gas is depends upon the pressure of gas. Greater the pressure of gas, greater its solubility. That's why when your lid is opening, then pressure will be decreased. As decreasing the pressure, the dissolved CO2 comes out. Why? Because pressure is decreased, solubility is also decreased. So this dissolved CO2 comes out. Clear, na, children?
Yes, sir.
So this is the physical equilibria is observed in these following types of equilibrium state. Now let me discuss about this one, children. That it is a chemical equilibrium. Children, copied now.
So once can you say definition,
Sir.
rate of dissolution, vaporization. Definition.
Rate of dissolution means the amount of oxygen or gas is dissolved in unit of time in particular volume of water or solvent. It's clear. Now rate of evaporation means the amount of gas is evaporized in unit of time. In unit of time, a particular volume of liquid. It's clear, children. Regarding this one, anybody doubt? Children, tell me.
No, sir, I'm asking definition for dissolution of gas in liquids. Writing.
Clear? ఇంకా ఏమైనా డౌట్స్ ఉన్నాయా?
No, sir. No, sir.
Right, children, let me discuss now. Let me go to the chemical equilibrium. Chemical equilibrium. Then what is chemical equilibrium? What is its characteristic properties? Okay, which laws are governing the chemical equilibrium? The total discussion will continue in this class. Now, this class is most important for NEET. Thermodynamics, two questions are asking, 2 to 3. Most highest weightage thermodynamics first year. Of course, this is also important for right. Let's discuss. What is chemical equilibrium? Chemical equilibrium means, okay, in a reversible reaction, in a chemical reversible reaction, not process, chemical reaction we are mentioning, the rate of forward reaction should be equals to rate of backward reaction. Such a state is called as chemical equilibrium or chemical equilibria. Right. For the example, children, I am taking a chemical reaction. A is equilibrium with B, means reversible reaction. Now, at this rate of forward reaction means conversion of A to B is a rate of forward reaction. Conversion of B to A, rate of backward reaction. At equilibrium state, rate of forward reaction should be equals to rate of
backward reaction.
Yes. Such a state is called as a chemical equilibrium. Just learn 1 second. Right. Reversible reaction. Reversible reaction. Reaction at which rate of forward reaction and rate of backward reaction. Rate of backward reactions, okay, are takes place with equal speed or rate. Equal speed is called as equilibrium state. Equilibrium state. That means equilibrium. So that it is called as, that state is called as a state is called as equilibrium state. Means chemical equilibrium. Chemical equilibrium. Chemical equilibrium. It's clear, na children? Rate of forward reaction should be equals to rate of backward reaction. Now, so let me continue with the graphical representations for equilibrium. So before going to this one, let me discuss about some terminology regarding with this one. Now, the first what I am using, that it is active mass. Active mass. Most important word. Active mass. Active mass is simply called as a molar concentration. Molar concentration. Molar concentration. This active mass is represented in between the square brackets. Now, which is equals to number of moles in V in liters. It's clear, children. Number of moles, already we know that weight of substance by molecular weight of substance. Simply, active mass means the mass of chemical substance. The mass of chemical substance that take part in that take part in chemical reaction. For the example, what I am taking, children, this is a solid material. This is a solid material. So this is solid material. Only top layer particles are whatever the amount. This is total amount. Children. Only this layer, top layer molecules are participate in the chemical reaction. After completion of this top layer, going to the next layer. After this one is next layer. After this one is next layer. After this one. Means this number of molecules or mass of molecules which are participate in the chemical reaction, such is called as the active mass. It's clear. Simply is called as molar concentration, that it is a n by v in liter. N is equal to weight by molecular weight, children. Now, neat point. Special point for neat. Special point. Right? The special point what I am giving, children, for solids and pure liquids. Active mass is taken as unit value. That means 1. So important for NEET. Based on this concept, questions will be asking, children. Now, for solids, active mass, pure liquids means solutions, active mass is not taken as 1. Only pure liquids means solvent. Active mass is taken as 1, means unit value. It's clear, children. Now, for the example, I am taking one more discussion. Active mass of find active mass of 8 grams of no, question is changing, just find the active mass of following gases, right? Find the active masses. Question just changing the question. 28 grams of N2, 8 grams of O2, and 1 gram of are present in 2 liter vessel. 2 liter vessel. Find active mass of each gas. Right, children? What is the active mass? Starting with nitrogen.
0.5, sir.
Okay, very good. First one, active mass of N2. Means active mass means N2 between the square brackets is equal. Its number of moles. Of this is B, children. So in case of B is 8 grams of oxygen. Now active mass of O2 means weight how many grams? 8 grams.
8 by 32.
Into 1 by 2. How many times? 4 times. 4 to 8. 1 by 8. 0.125. Okay? Clear na, children? Right, cheppandra.
Yes, sir. Yes, sir. Sir, why you multiplied by 1 by 2, sir?
Volume na. This is 2 liters na. By lo ne kada undi idi. Number of moles is equal to N by V na. N by V. This is number of moles. By volume undi kada. N into 1 by V. Simple. Okay.
Okay.
Now going to the next one, children. Now, this is a 1 gram of helium, C. Now, active mass of helium is taken as 1 by, its atomic weight is 4 into 1 by 2 is equal to 0.125. It's clear, na children?
Yes, sir.
Children,
Yes, sir.
so, can you solve my problem? I am giving the problem.
Sir, helium is not a pure liquid, sir.
The gas.
Yes, sir.
Okay, right. Now, children, find active mass of 5.6 liters of N2 at STP. నేను O2 తీసుకుంటున్నా తల్లి. Okay, O2 I am taking. O2 at STP. Can anybody solve this problem?
What is the capacity of the vessel, sir?
Huh?
How many liters